Sir, इसी वाले सर के पास Yeah, good afternoon, all of you. Is my voice is audible? Is I'm audible clearly? Yes.
Yes, sir.
Okay. You can scan this QR code for the attendance for this session. all of you had scanned this QR code. Yes. सभी ने स्कैन कर लिया QR code. Those who are not scanned, also those who are not late joining, I will share again at the end of the session. You can scan. So let us continue. Yes. So in the previous lab, if you remember, we are basically performing, I think we are performing one session for this one. So I will complete this one later on. Okay. So as we have, the last week, we have just started the memory management, and we have learned about the uh, continuous memory allocation, or we can say continuous allocation technique. So today we are going to implement the experiment number 5. Okay. So all of you can write down this experiment number 5. That is your implementation of continuous allocation technique. Okay. By using your different method like worst fit method, best fit method, and first fit method. So we have already learned the concept. So I will explain once again the conceptual part. Then we will write a C program for this one, and whatever problem that we have discussed in our class, now we will see whether we are going to able to implement the problems or not. Okay, so if you see the list of experiment, what we have performed till now, so let me highlight this one, so what we have completed. Now I think we have completed this one. And we have also completed the blank test algorithm. Yes or no? Did we complete it? Yes? Yes or no?
Yes, sir.
Those I'm highlighting, they are already completed. Okay. And we are also completed the producer consumer problem using the semaphore. Okay, so we are left with the reader writer problem that I will solve. Okay. Then today we are going to implement this one, the continuous memory allocation technique for this worst fit and best fit and first fit technique. Okay, and the later lab we will discuss about different techniques like continuous allocation using the array or linked list technique for non-continuous allocation and some indirect allocation like indexing technique. Fine, and so, again we will talk about something about what we have already discussed external fragmentation and internal fragmentation, but how we can perform this external fragmentation and internal calculation of this external fragmentation and internal fragmentation for space free form. Okay, we will later on see this one. So in today's lecture or today's class, lab class, we are going to solve this one. So all of you may write this one as a name of the experiment. Okay, all of you write down. This is your name of the experiment. That is using C program implementation of continuous allocation technique or continuous memory allocation technique. Okay. So Okay, so let us start then. So it is this screen is visible to all of you? Is my screen is visible to all of you? Yes? Is my screen is visible? Yeah? Is my screen is visible? Is my audible? I'm audible to all of you?
Yes, sir.
Okay, the screen is visible.
Yes, sir.
Okay, fine. So as we have known from the theoretical classes, so there is two type of memory allocation. Okay, memory allocation means memory allocation मतलब क्या होता है? Now we are having an main memory. हम लोग के पास दो टाइप के मेमोरी बोलेंगे, ठीक है? There are different types of memory, but in case of operating system, we will talk about only two types. One I understand, which is main memory, which is called your primary memory also, sometimes it is called RAM. And there is one more memory, okay, एक और memory है which is larger in shape, okay. अगर the RAM is smaller in size, okay, RAM का जो size है आपका बहुत ही छोटा है compared to the secondary memory or hard disk. But what is the difference? The accessing time. The accessing time is how much time the CPU will require to access the data from secondary memory and main memory. The accessing time of main memory is very much smaller compared to the accessing time of your secondary memory. So what memory allocation say? Now what will happen? As we know, memories are divided into different.
हेलो सर, हेलो
Yes, बोलिए.
सर। किसी का कनेक्ट नहीं हो पा रहा सर।
I'm
बहुत जन का ग्रुप में सब मैसेज कर रहा।
about to कर रहा हूँ, पता नहीं करेक्ट क्यों नहीं हो रहा है. Let's see, I'm admit तो कर दे सबको. But they are
एरर
not able
मैसेज
to
शो
send.
कर रहा।
I'm allowing everyone, no? सबको allow कर रही हूँ. Right. So maybe some network issue maybe from there, and I think so. शायद वो लोग का network issue होगा उनका इनसे. So we will wait for another 2 minutes. Okay, let me wait for another 2 minutes. Let me resolve this issue. Then we will start the session. Okay. Say the meeting ID. Yes, I think most of you are joined now. Yes. शायद so join हो रहा है अभी सब लोग. Join हो गए सब लोग. Okay, just inform the friend to now request send the request for join now. So I will admit them. Okay, so let us continue. So as we know, what happened, either it is secondary memory or primary memory. The memories are basically divided into blocks या फिर word बोलते हैं, ठीक है? आपका जो memory है वो words में या फिर blocks में divide होते हैं, ठीक है? Now this size of the block and size of the word can be anything. Okay, generally sometimes we will take the block size is 32 bit, or sometimes we will take 64 bit, or sometimes we will take 8 bit or 16 bit. Now it depend upon what architecture we are following. Okay, what architecture we are following. Fine. Now there will be in block size. Block. Okay. Now suppose it is 32 bit. अगर मैं लेता हूँ block. Now each of this block is 32 bit. That means there are 4 bytes. I can say there are 4 bytes. Now अगर हम लोग बोलेंगे 32 bit का block है, तो कितने होंगे? हर एक 8 bit का एक byte होता है, मतलब block होता है. Now there will be a 8 bit, 4 8 bit blocks. Okay. Clear this thing how the memory is designed. Okay, this is completely an architecture part, but I'm just explaining for a conceptual view. Now, this will be divided like this, okay, blockwise. Fine. Now, each of this block will have an address. Okay, each of this block will have an address. Now, similarly, each of this block, I can say each of this block so each of block, this block will be have a address. Okay, so if I say the address of this one will be suppose 0. Now what will this one? This one will be 8. So this one will be 16. This will be 24. This will be 32. Okay, so in between there is again 1, 2, 3, 7 up to 7. Okay, so this will be 7. Okay, go to 7. Now this will be 15. This will be 23. This will be 31. Similarly, it will continue. That will be continue from 32. Okay, to it will be 63. Now it will be 64. Say आपका continue हो कितना 127, and this process will continue. This process will be continue. Suppose the size of 2n अगर बोलेंगे, ठीक है, size of 2n, then it will be 2 to the power n minus 1. Okay, the final address will be 2 to the power of n minus 1 will be there. Fine. Now this is representation. Similarly, आपका जो main memory में भी same representation रहेगा. Now each block of 32 size, and each will be having size of some starting from 0. Okay, starting from 0 it will be 31. Now it will be, starting from 0. Now it will be, if I address this one, okay, right. So this will be 31. Now it will be 32, say, again it will be 63, and this process will also continue. If I say size of m blocks are there, the final will be 2 to the power of m minus 1. Okay, if there is m blocks, okay, if there is m blocks, there is, now if there is n blocks, then final n blocks, then size is 2 to the power n minus 1. If there is m blocks, then size is this one. And we are clearly know that now n is much greater than n here. Okay, just remember. Okay, the n is much greater than n here, because size of the main memory is very less. Now what happened? So what memory allocation is saying? Okay, okay, what the memory allocation is saying? There are two types of memory allocation. One is your continuous allocation. One is your continuous allocation. Second one is non-continuous allocation. So today we are going to talk about continuous allocation. So what the continuous allocation क्या बोलता है? Now suppose एक program है मेरा. Now suppose a program P0 है. Now suppose the program P0 है. Now suppose program P0 start होगा 64 से. ठीक है? Now I am assuming that the program is something about 64 bytes. Okay. So it will, how many blocks it will occupy? It will occupy 2 blocks. Yes or no? if I say my program is 64 bytes, okay, now if I say program P0, now program P0 is 64 bytes. If I'm saying the program is how many bytes? 64 bytes. Okay, so as I know, my memory blocks are 32 blocks, 32 bytes block. So how many blocks is going to appear? How many blocks is going to occupy? It is going to occupy exactly 2 blocks. Okay, exactly 2 blocks. Now what is the address? Address will be starting from 64 to, it will be how much? Again, I will add 32 to this one. It will be 32 means 100 by 32 to 159. So address will be 64 से लेकर तो 159 तक रहेगा. Now when I will store in continuous memory location, okay, when I store in continuous memory location, suppose the P0 is started storing from here. अब P0 को कहाँ से store करते हैं हम लोग? यहाँ से store करते हैं. तो continuous memory location में क्या बोलता है? All this program. Now suppose this P0 consists of 100 instruction. P0 consists of how many instruction? Now I0 to I100. Okay. Now this 100 instruction is going to store on I0 to I99. This 100 instruction going to store continuously. That means it will be going to store in continuous manner. If we starting from this address, or suppose this address is, let me say it is 255. Now it will start from 255, and we're going to occupy this entire block, and this is also going to entire one more block because it's 64 bytes. So I will add 64 to it, 225 plus 64, which is equal to 9, it will be 390. Now it will continuously going to store 390. So this is a continuous memory allocation. So what the continuous memory allocation say? The memory will be allocated whenever we transform certain program. Okay, so whenever we shift certain program from secondary memory to okay, whenever we shift this program P0 from secondary memory to primary memory, okay, now this will continuously allocated. Now you can see this is occupied 2 blocks, now this also be occupied 2 blocks continuously. Okay, and second thing it is the memory address may not be same. Here the memory address starting with 64 and ending with 159. Here the memory address is starting with 255, ending with 319. So this particular memory address is called physical address. Okay, the address of main memory is called your physical address, and the address of secondary memory is called your logical address. Fine. So this is the concept of what is continuous memory allocation. What is continuous memory allocation? If I say it is not continuous, then what will happen? Is it clear to all of you what is continuous memory allocation? Is it clear to all of you? Is any doubt regarding continuous memory allocation?
सर
Yes, which here?
सेकेंडरी मेमोरी में सारे ब्लॉक का साइज सेम है या डिफरेंट है?
सारे ब्लॉक का साइज सेम रहेगा. ठीक है, ये आपका
वहाँ पे 127 नहीं होगा ना?
If I say it is 32, then next will be क्या होगा? 63, then it will be 63 plus 32 will be how much? Now it will be
96.
96. 96.
32 या 37?
32. I am saying 32. The block size is 32.
Yes, sir, 96.
92. Then it will be 127. Fine. It will be 147. The block size will remain same because it will depend upon your architecture. Okay. आपका हार्डवेयर आर्किटेक्चर पे डिपेंड होता है, और याद रखना ये ब्लॉक साइज हमेशा मेमोरी ब्लॉक साइज सेम रहेगा, वेरिएबल नहीं रहता है. मतलब एक ब्लॉक हो गया आपका 64 बिट का, अगर दूसरा ब्लॉक 128 बिट, इट इज नॉट अलाउड. ओके, इट विल बी इन सेम ब्लॉक साइज. फाइन. यस, एनी मोर डाउट? एनीवन हैविंग एनी अदर डाउट? सम इशू विद टुडे जूम. ओके, मेरे को लग रहा है कुछ इशू है आज आपके साथ. Otherwise, this problem when rejoining वाला problem नहीं आना.
Yes, sir. काफी लोगों को हो रहा है.
So So any other doubt regarding this continuous memory allocation? So one thing is clear, you have to understand प्रोग्राम का जितने भी साइज होगा और जितने भी इंस्ट्रक्शन होगा, सिंपल थिंग है. कंटिन्यूस मेमोरी एलोकेशन क्या बोलता है, जब हम प्रोग्राम को सेकेंडरी मेमोरी से प्राइमरी मेमोरी में लाएंगे, the size and the number of instruction will be stored in a main memory continuously. Okay, but if it is non-continuous, now one of the main problem of continuous allocation is what? External fragmentation. Yes or no? One of the major problem of continuous memory allocation is external fragmentation. So we have to organize this memory such a way that the wastage should be less. Again, external fragmentation is one of the major concern because their memory is wasted. हम लोगों ने theoretical class में देखा था, even if the space is available, total space is available, but we cannot able to assign a process to the memory because they are not available in continuous fashion. So there is a wastage of memory. To avoid this one, we are using the concept of non-continuous. So in a non-continuous, what I will do, जब P0 का हम store करेंगे, so some part of P0, suppose I say 32 bytes are stored here, and the rest 32 byte P0, if it is available, now I will store here. Now you can see here what has happened. Now the P0 is stored in a primary memory in two parts. Now this is my first part, okay, where I store the instruction number I0 से लेके I499 तक स्टोर किए. Okay, now हम लोग यहाँ पे कितना स्टोर किया, इंस्ट्रक्शन नंबर I500 से, suppose it is 1000 instruction. So I'm considering there is I0 से 199. So it will be 500 से कितना स्टोर होगा, इंस्ट्रक्शन नंबर 199. Now this is a non-continuous allocation. That means now the process P0, okay, now process P0 which is stored in this secondary memory, when I shifted to the primary memory, now it is stored in a non-continuous fashion. That means it is stored in partial manner. The partial programs are stored at one place and the partial program are stored at another place. So why we are using non-continuous memory allocation? Non-continuous memory allocation basically used to avoid external fragmentation. Okay, to avoid the concept of avoid the disadvantage. Basically, we are having the disadvantage of external fragmentation. To avoid this external fragmentation, we will use the non-continuous allocation. So we will not talk about today non-continuous allocation. So we will talk about continuous allocation. Now, if I say these memories are allocated continuously, if I say this memory is allocated continuously, if it is allocated continuously, okay, if it is allocated continuously, so how it will be allocated? Now it will be allocated something like this. Now it will be allocated something like this. Okay. Now there are three different algorithms. We know that for continuous memory allocation, there are three different algorithms we have already studied in the class. First one is your first fit. Very first algorithm is your first fit. The second algorithm is your first fit. And the third algorithm is your best fit. Yes or no? Yes? Is it correct? Is I correct?
Yes, sir.
Yes?
Yes,
If I'm saying non-continuous allocation, there are three techniques we are going to use. Okay, for the non-continuous allocation, we have to use three different techniques. One is your first fit technique. Either I can use first fit, worst fit, and best fit. But in the class, we have already studied the worst fit is the best one. Out of these three techniques, the worst fit is best one. So let me quickly explain these three algorithms first, one by one. One by one, we will explain and I will implement and show you the example. Okay, so let me clear this thing. I hope it is clear to all of you what you mean by continuous allocation. Is any doubt? Still any doubt regarding continuous allocation? Because this is very important concept regarding the memory management. Okay, if it is not clear, then we will not understand the non-continuous. Why we need non-continuous allocation? Then what is the need of paging and segmentation? Or we can say what is the need of virtual memory also. Fine. So let us first discuss the very first algorithm. So as we know, the very first algorithm is first fit algorithms. Okay. Again, we will going to discuss your variable size partition. Okay, again we know that the continuous allocation is two types. One is the fixed size partition and variable size partition. Here we are going to study about the variable size partition. Okay, now if I'm saying, now what I will do, so first of all, suppose this is my memory block we are having. Okay, now suppose let me, so I will, what I will do, I will divide in different block of different, so entire memory will be divided into different blocks of memory blocks. Okay, so whenever we go for the first fit algorithm, so what we have to do now, first of all, very first process that is requested, so it will be start from the very first block. Okay, so every time we will, the process is requested, every time जब कभी भी एक process request करेगा तो हम लोग हमेशा कहाँ से start करेंगे, very first block. Okay, and the first block which is suitable enough, सबसे पहला block जो suitable enough होगा, that block will be assigned. So same if you see the algorithm here. So first of all, what you have to do now, first of all, step number one, get the number of process and number of block. Okay, so I will take this input as an input. So input क्या लेना है आपको, how many process are there which is requesting for the memory block and how many blocks are available. Okay, how many blocks are available. Then after that we will get, once the number of process and number of block is clear, so what we will do after that, we will get a size of each block and process requested. That means I will define what are the size of each block. Okay, what are the size of each block. So we will define basically what is size of each block. Okay, let me define this x and y. Okay, so I will define each size. Along with that, each process which is requested. Now for allocation, okay, now for this is the logic for the allocation. Now I will check if the block size is greater than equal to process size. Okay, there will be for loop which is starting for very first loop. Okay, before here I will use a for loop because I have to check from the very first node now. So while this running this for loop, okay, while this running this for loop, what I will do, I will check the block size. If the block size is greater than equal to process size, so I will allocate the process. Okay, otherwise we will move to the next block. Simple. अगर हम लोग चेक करेंगे तो process size P0 होगा. Okay, I will check if the block size is greater than equal to P0, if it is greater than P0, then I will assign this block to the particular process. Otherwise I will move to the next process. And this process, this entire thing will continue until all the process is allocated, or some process are not suitable to, we can say, it is not suitable to assign any block. Okay, then finally we will display the process which block is allocated. Okay, this is the algorithm part. Okay, this is the algorithm part for this particular first fit method. If you want, you can write this algorithm. Just write down this algorithm because you have to write in lab copy. So write down the steps, what steps we have to follow. So let me meanwhile copy this program. Okay, program for it. Then I will show you how it will be working. Let me first copy this program. So all of you write down this algorithm part for the first fit. just copy this one. At the time will be ended, you are requested to again join the same link. Okay. So again, I'm sharing the QR code. Those who are not given the attendance. Okay. Those who are not given the attendance. Okay, all of you rejoin the link again. Okay, then I will discuss the programming part there.